Welcome to the Quantum Ireland podcast, your gateway to the fascinating world of quantum computing, science and technology. Our podcast delves into cutting-edge research, groundbreaking discoveries and innovative applications emerging from Ireland's vibrant quantum community. Join us on this journey as we unravel the mysteries of quantum computing and uncover the endless possibilities it holds for the future. Get ready to dive deep into the quantum revolution with the Quantum Ireland podcast. Hi everybody, it is Mark Kelly. I hope you're doing really well today. And a part of our Quantum Computing Ireland podcast, I'm very happy to welcome John Gould. John is Associate Professor of Physics at Trinity College Dublin. Dr. John, thank you very much for joining us on the show today.
Thanks, Mark.
So, reading your background and doing a little bit of research into this area, I had quite a few questions to start off with, but I'm going to take it really basic. How did you get into this world? What were some of your inspirations to do this? We're obviously going to be kind of talking about the world of kind of quantum computing as well, but I'm guessing you probably would have had a lot of influences to want to kind of navigate you kind of closely towards this area. Maybe you've thought about in the past, or maybe kind of indirectly, but it'd be great to hear about that.
Yeah, I suppose it starts off really all the way back when I was in school. I guess I liked science in general. That was my kind of passion when I was in school as a subject. I kind of excelled in that, and mathematics. And when you started doing leaving cert chemistry, leaving cert physics, started to learn a little bit about. I mean, especially in leaving cert chemistry, at least in my time, they would have taught you a little bit about the beginnings of atomic theory, and I thought the history of it was kind of fascinating. And I always wondered, how does one become someone that sort of makes discoveries in quantum mechanics. And then I heard about theoretical physics. I actually originally maybe thought about going to Dublin to study it, but then I realized that, I could do the same in UCC just by combining kind of, maths and physics topics. And I actually stayed there for a PhD. I had a very good PhD supervisor, Thomas Bush, who came from Europe. So he was working with a very famous group doing kind of stuff in quantum engineering. And I guess, from there, I kind of just took off really and went on a very kind of long trajectory through different countries, and eventually found myself back in Ireland starting a research group. And but the passion, was kind of always there, just to try to understand the world at the kind of fundamental level. And I remember reading like John Gribben's books about quantum mechanics, or popular science books, when I was a leaving cert student, and thinking it was really fascinating. So where he talked about the Schrödinger cat paradox and the double slit experiment and all these kind of weird paradox-like kind of phenomenon in quantum mechanics, and I wanted to kind of know more about it,
Tell us a little bit about the countries that you've worked in and some of the work that you've done as well.
Yeah, so after my PhD was kind of ended 2009, started 2010, and obviously that wasn't the best time in Europe. It was kind of, just, well in the throes of recession. So, there was a Center for Quantum Technologies built in Singapore. That's already, quite some time ago. They were quite far, like quite long-sighted, and not, well, I would say long-sighted is the wrong word, but like they were, let's say, quite ahead of their time in trying to build up kind of a research base there. And of course, they had a lot of money over in Asia. Didn't have a recession like we had in Europe. So I found myself over there. And in the meantime, I'd also applied for a Marie Curie fellowship at the University of Oxford in the quantum information group. And actually, while I was in Singapore, after 8 months, I found out that I got the fellowship. So I moved back to the UK. I spent about 3 years in Oxford working in a group that was really a hardcore quantum information group. And there I started to really develop my own kind of my own topic, which was interface of thermodynamics with quantum physics. And then I realized that I needed to learn a little bit more about what's called statistical physics, because that was sort of something that I was relatively weak in. So I decided to apply for a postdoctoral position in basically a place called the Abdus Salam Center for Theoretical Physics in Trieste. It's actually UNESCO UNESCO Center. It was founded by a guy called Abdus Salam, who was the first Muslim Nobel laureate. He was a Pakistani physicist, very famous, won the Nobel Prize, and he started an institute which basically focused on, first of all, on research and excellent research in condensed matter physics and high energy physics, but also it promoted the development of science in in developing countries in the third world. So, you had a lot of students from sub-Saharan Africa there and stuff like that. So that you had a kind of, this angle to it as well. So I was working there for quite some time, quite happy there. And I got basically the opportunity to come back to Ireland when I was awarded this Royal Society University Research Fellowship, which are very prestigious fellowships for early career researchers. You can take them anywhere in the UK or in Ireland. And so I was talking with Trinity about coming back, and the way it goes when you're trying to get a faculty position can be difficult to negotiate one that sort of has terms and conditions that are right for you, especially in my case. We were moving a young family, and my first son was born in Italy. But in the end, it worked out. I got an ERC starting grant, which is a big grant to start a research group. And so, essentially, I got a permanent position on the back of those two awards. And I've gone from strength to strength really since then. I've been here working in Trinity for the best part of kind of 6 years or so. And my research group has grown significantly, and the activity in quantum science has grown, significantly due to the fact that we've developed, educational programs and research programs. We've actually extended the faculty in that direction as well. So, I'd like to take some credit for playing a decent role in being a catalyst for that. But other people are doing great work as well. So.
Brilliant. It's a great story as well. So many different turns along the way, and people that you've actually learned from that help shape you too. When you talk about your work and like a research focus and impact, and your work focused on the thermodynamics of quantum technologies and the non-equilibrium statistical mechanics, how do you envision your research contributing to the future advancements in quantum technology?
So there's as a theoretical physicist or a quantum physicist, you're not, strictly speaking, motivated by technology. It happens that we're in a good place with quantum science at the moment because there's significant interest both at a public, from a public perspective, so governments, but also multinational private sector investment in technologies that harness quantum effects to do things that are interesting. So quantum computation being one of them, quantum sensing, quantum cryptography, a lot of that kind of stuff. So that would not motivate me per se as a scientist, but and not that I'm jumping on the bandwagon or anything like that, but it would be unwise not to get involved in that, given that you have the right background to understand those things. So that's one side of things with quantum mechanics. We can talk about whatever aspect of quantum mechanics you want me to talk about, but non-equilibrium physics then is a whole different kind of area of physics, which doesn't necessarily have to have anything to do with quantum systems. Non-equilibrium physics just means essentially things that are not static, right? So equilibrium means like your body, for example, is not in equilibrium. The day you reach thermal equilibrium is going to be a sad day for your family, right? Because you're going to be dead. You reach the same temperature as the environment, you're in thermal equilibrium. Your body is at whatever it is, a certain temperature, independent of whether it's cold or hot outside, and your body does remarkable processes to maintain that body temperature independently of your surrounding. But this is not the same as a glass of water. If you leave a glass of water in a room at 40 degrees, the glass of water will eventually become 40 degrees as well through equilibration. So I'm interested in that phenomenon of how non-equilibrium systems reach equilibrium, so reach some finite temperature in finite time. And, obviously this has technological relevance as well, because the quantum computer or quantum technology is a highly non-equilibrium system, and you're often fighting against the detrimental effects of the environment, like so heating effects. That's why when you see these photographs of quantum computers, they look like chandeliers. The chandelier is actually a cooling device that's trying to isolate the system, from the rest of the world, right? So that type of physics is important for quantum technologies as well. But it's not the only thing I'm interested in. I'm also interested in quantum simulation, which is the idea of actually using near-term quantum devices to do interesting things to simulate other quantum systems, which is a very hard task. We can get into detail on any one specific point of this.
Yeah, and we could have like 6 different episodes on this, from the theoretical concepts and the kind of real world applications. That's probably where I wanted to try to take it, just to kind of open the eyes for the novices around here, where they can actually see some of the real world applications of those concepts?
Yeah. Okay. So first of all, I mean, let's first talk maybe about just quantum mechanics itself as a theory. So, I mean, it's a framework that physicists have, which was developed in the early part of the 20th century. And it was discovered, like many theories, by almost a sort of series of mistakes. So, I mean, at that time, there were some problems that people couldn't figure out with the most sort of advanced theory of the time, which was actually statistical mechanics. So they couldn't understand, for example, the emission spectra of a black body, right, which is called a black body. The reason people were studying that was actually because sodium street lighting in Germany was sort of coming on the market, and there was a problem. We wanted to understand the emission spectra of sodium and stuff like that. And a guy called Max Planck basically was doing his PhD thesis, and there's a famous quote from his PhD thesis where he says, "In an act of desperation, I let the energy equal to be a multiple of the frequency." So this is the quantization of energy. Basically, one of the core premises of the early quantum mechanics was that energy is absorbed and emitted in discrete bundles of energy with some multiplicative constant, which is now known as Planck's constant. Okay, so that's sort of quantization of energy. And then a lot of theorists jumped into this and said, "Well, that's very interesting." And they started to develop a mathematical framework that was consistent, in which they understood where this theory kind of fell, right? So it was kind of built around 30s by people like Erwin Schrödinger, Paul Dirac, Werner Heisenberg, and many, many more. And it's a really radically different way of thinking about reality. So the repercussions of quantum theory are profound. For example, measurements are very strange in quantum physics. So if you have a quantum system, it's obviously can be in a number of different states. Okay, so for example, if you have an atom, it can be excited only in discrete discrete multiples of some fundamental energy, and that's not actually true, by the way. But it can only emit and absorb at certain multiples of given energies or whatever frequencies, and the point is that one of the consequences of the theory is that the quantum system can be in multiple states simultaneously. That's something called a superposition. So really, atoms can be here, there, and everywhere at the same time, which is a very hard concept for us to kind of understand. But the weird thing is that as soon as you measure a quantum system like an atom, an electron, or a photon, or whatever, you get an outcome which is completely random, that occurs with some probability, and you do the experiment over and over again, you get different outcomes, and you build up the probability for an atom to be somewhere, okay? So this is probabilistic sort of influence of the measurement, etc., that makes quantum mechanics a bit wacky, right? Like, so electrons and photons and different quantum particles behave very differently when they're being measured than when they're not being measured, okay?
I'm guessing there's quite a bit of challenges in quantum technologies in terms of how you're actually going to address them. How do they evolve? How do you then try to address those as they evolve? Because
exactly.
You're not looking at this through a regular lens.
Yeah,
you need to look at it in a completely different lens, which I can only imagine you would want to be hungover coming in and doing this work.
No, but like I guess so. Here's the thing that after those kind of implications of the theory were found, and all of that. I mean, many of the fundamental quantum features, were weak. They were kind of brushed over a little bit by people because at that point in time, technologically, the experimentalists weren't really able to isolate, individual quantum systems very well in the laboratory. Like, so it took a lot longer, like right up until like the last couple of decades. Now people can really manipulate single quantum systems and quantum systems comprising of many parts and observe their quantum mechanical behavior over long time scales, right? So then, I mean, the whole thing of quantum technology is using some of these like seemingly wacky features to try to do tasks which are not possible using the laws of classical physics. And so quantum computation, certain algorithms can be made perform better using quantum logic than with classical logic. Not all, but some. Quantum sensing is another area. You can get more accurate reading or more precise reading of precision measurements if you use a quantum sensor as opposed to a classical sensor, and so on. So quantum technologies is a relatively new thing that's emerged, where people now have the ability to really control quantum systems for timescales that are sufficient to do something interesting. The problem is quantum systems are extremely fragile. If you measure them, or if they get measured by a dust particle in the environment, they start to degrade their quality. That's something called decoherence, and you're always fighting against that from a technological perspective. So indeed, it poses significant problems to build scalable devices, and it's one of the fundamental reasons why we still haven't got any universal quantum computer at the moment. You have kind of systems which are doing something, but it's not necessarily clear if you can make them in their current state perform anything better than a supercomputer, just because they're so fragile, because they don't like being measured, and et cetera, et cetera.
So if we build on the quantum education initiative kind of topic, you've been instrumental in integrating the quantum information theory into the physics syllabus at Trinity and launching the MSc in quantum science and technologies. What pursued you, like, to drive these educational initiatives, but also to take into consideration the research, the landscape, all happening in Ireland? Because you could have done so many other different types of things. I was quite interested to know why you followed through with that one.
No, that's a really good question, and I ask myself the same question sometimes, because it was a huge amount of work. And I mean, what I want to do is go and do my research group, but I mean, I guess there was there's two things. I mean, I am Irish, right? So I mean, I really felt that the whole kind of quantum science and technology initiatives have been, really driving full power ahead in a lot of other kind of Western countries, a lot of European countries. There's a very significant investment, very little in Ireland. And I remember before the pandemic being in a sort of brainstorming meeting at Science Foundation Ireland in January 2020, and they were discussing about what we could do. I mean, obviously the departments were getting kind of worried that they weren't invested in this, but they saw it taking off worldwide, but nothing of significant scale happening in Ireland. And it takes years and decades of investment in fundamental science. If you compare Ireland now is not particularly good in investing in basic science, right? So it typically funds applicative science. But with quantum physics, because it's so technical, you have to be your economy has to be invested in fundamental science, and then a technological breakthrough happens, and you have the people around which are able to kind of take up the reins there. But we didn't have those people in Ireland, and I mean, I really felt that one of the things we could do in Trinity, if we got funding for it, was to start the kind of graduate level education in the topic. And by de facto, then that would do two things. It would obviously get skilled labor force out. Now, that labor force, unfortunately, nowadays, it's the people graduating from MSc are often immigrating because their startups are in different countries. But we can come back to that. I'm trying to do something about that as well at the moment. But also, the other reason was it allowed us to extend the faculty. We got two excellent junior professor hires that, on the basis of the MSc program, which also are excellent researchers. So I saw it as an opportunity just to grow the activity in Dublin, because you need to reach some critical mass. Without a critical mass, you can't have a national initiative. So I felt a national obligation for that,
Yeah, no, and I appreciate that. And, it's why I created AI Ireland, the AI Awards, and, why I'm trying to support on quantum, because I feel that you have to start somewhere. And I think you have to be part of the solution, because like, if you're not part of the solution, then you can speak about it for all day, right? But until you do that, and it pretty kind of ties into my next question. So under collaboration and partnerships, I had Mariana on the show from Sandbox.
Oh
yeah, a couple of weeks ago, and we're going to be, by the time people listen to this, they probably have listened to that episode as well. Tell me about some of the partnerships that you've had. You've got Microsoft, IBM, Sandbox. And I also like female-only scholarship schemes. And how do these partnerships align with your research objectives? And you kind of touched on people having to emigrate for jobs and stuff like that. Tell me about your kind of thinking with that, because from speaking to Mariana, and I'm going to let you answer now, there seems like there's a lot of thought put into that process, where I've been in the world of staffing for 16 years. Not necessarily too much thought that's always put in, and more thought in at the end. So I really thought there was a lot of design thinking and leading with empathy with it.
Sure, Mark. That's I think it's the perfect kind of question to come after the. So again, as I said, the educational program not only kind of builds a culture and it creates people with expertise in the areas that you want them, and also allows you to extend your faculty. I mean, the other thing that it allowed us to do, because we start the MSc with the idea that it would be an MSc that we would have significant input from like private sector if we could. And because I've been around the world, I know different people. I know a lot of people who have left their faculty positions to enter the startup business. I was able to contact them. Sometimes they would come in person, talk to our students, or they would give a Zoom talk if they couldn't make it in person. It was great. But the other thing, of course, that allowed us to do in the faculty here was actually discuss research with some of the startup companies and some of the multinationals, because actually the type of work that they're doing is not a million miles away from what we do in the research groups here. In fact, startups in quantum computing are kind of very close to research groups that are functioning without the kind of heavy bureaucracy of public sector work. Like they don't do teaching, they don't do administration. They're really focused on, it's a bit more targeted, the work. So we were able to forge really nice collaborations with not only like multinational companies like IBM, like Microsoft, and I can tell you about more specific details about some of the schemes we have with them, but also, like you mentioned, Sandbox. Sandbox, the collaboration with them actually arose. I'm trying to remember how the contact was made, but Mariana's in kind of, again, a former academic. I think she was she was a maths professor in New York, and so it's very easy to talk to her. And one of the things that we discussed when someone put me in contact with her was, and bear in mind that our masters, when it was formed, was fairly unique on an international level. So a lot of those companies were interested in it. Like people hadn't really thought about a tailored program like ours, which would blend, kind of industry. We actually spent a year going around asking people in industry, if you had a graduate from an MSc program in quantum technologies, what would you like them to be? And they all would have said, well, we just don't want them to be complete, geniuses in quantum mechanics. We also want them to be very solidly grounded in classical computer programming. So we have an element with that. We have iCheck involved in our MSc. But the other thing that's nice about starting something from ground up, like we did, is that you have an opportunity to kind of set a different culture, right? Like, so, I mean, if you look, for example, in general in the physical sciences, like, for example, females are very poorly represented, right? And if you think about it from a holistic perspective, the more diversity you have in a ecosystem or culture, the better the collective decision-making and collective outputs will be. It doesn't mean to say that the individuals, their gender or their sexuality or where they're from matters. That's not true. But collectively, the more diversity you have, actually the better kind of collective output you'll have from a group of people. And my interest was always not just in education, not just in research, but fundamentally building an ecosystem in Ireland and focusing on some area which I think we can gain traction, which is the sort of, we're in a unique position here, in Ireland, because we have the footprint of multinational companies that have huge investment in quantum technology hardware. So my idea was somehow at the MSc was to focus on the software and application end of things and exploit the connections with the multinationals for hardware access, right? So, but with Sandbox, we organize a diversity dinner, diversity in quantum, and this year we actually will start a scholarship program for another underrepresented group of students in quantum technologies, which is students from the global south. So we have two scholarships on offer this year, which are funded fully by Sandbox, really top-class scholarships, like full stipend, full accommodation costs, really fantastic. And they were very obliging, and it was just a matter of putting in the time with them, making sure we're on the same wavelength. I mean, Sandbox are a company which are very, very keen on developing an international kind of quantum society, so They were very obliging. IBM, they actually have R&D in Ireland, right? So they do a small R&D group working on quantum technologies. And a couple of years ago, they introduced a pre-doctoral program with Trinity, which basically, it's a very nice program. It allows, if you find some overlap, if they find overlap with PIs in Trinity, basically, in certain areas, I think AI is one, quantum is another. I forget what the other one is. But if you find overlap with a research group, they will give you a PhD student, but that PhD student who's selected by IBM is an IBM employee. Okay, so they have a better salary, good conditions, and also access to the IBM technology stack. So I have one student who's an IBM employee in my group, and he can access the quantum computing technology that's remote in US. So that's the IBM one. Microsoft, we have a very good relationship with. So they're a slightly different kind of structure in Ireland because they don't have any real R&D in quantum technology in Ireland, right? But they're very keen on. I mean, Microsoft is and always will be probably a software company first of all, right? But they're very keen. What Microsoft do is they have an Azure platform where you can access different quantum startups technologies. And of course, they're very keen from a business perspective in stimulating growth in that area because they want to be a provider of hardware access through their software platform, and they've given money for research, but gifted money. They just, they say, look, we're willing to gift you money to do work in quantum simulation. But also they've been hugely supportive and have donated money for female-only scholarships to the MSc program, which has been running now for 3 years. Has been hugely successful. So it's allowed girls to do MSc in Trinity that otherwise wouldn't be able to because of financial constraints. And we need to. Last year I think we almost reached a 50-50 gender balance, which is unheard of in a STEM kind of topic like quantum technology. But ultimately, a lot of diversity issues can be kind of if you really put money on the table, because most of our female students are coming from abroad, yeah. So the problem of getting more females working in STEM topics is very nuanced, and there's various different aspects to it, and it starts probably already in primary school and before, and the way we even can precondition or gender assign roles to kids. But if you look in the graduates of, say, Iran from the top universities in physics, you'll find more females than males in the graduate years, right? So, but the problem is that we often can't hire them because there's financial constraints or, whatever. So these type of mechanisms are super important to enhance the diversity. And then there's a kind of clusterization effect where, other females who maybe are thinking of pursuing a career, but they look in photographs and they see just a bunch of bearded men and they're like, screw this, So they see other females and then they realize that it's actually, so it is what it is, right? You try to stimulate that diversity. And I think we've done that very successfully. It makes the environment great. I'm really looking forward to the Sandbox initiative, but I'm very passionate about that diversity issue in general and building teams.
It's multifaceted because when you get it right and you're on the right side of it, the dominoes effect really play out, that more people get involved. And then it becomes, a self-fulfilling prophecy. But I do think you need to be very conscious of the bias and then, work on it. And I think this is a great example of doing that. John, we've covered so much in such a little time. Thank you very much for your time today. You've been listening to the Quantum Computing Ireland podcast. My name is Mark Kelly, and I've been speaking to Dr. John Gould, Associate Professor of Physics at Trinity College Dublin. John, thanks again for your time.
No worries, Mark. Thanks.
Thank you for tuning in to the Quantum Ireland podcast. Stay connected with us for future episodes where we'll continue to explore the mysteries of the quantum realm and keep you updated on the latest developments from Ireland's quantum community. Don't forget to subscribe, rate and review the podcast to help us reach more curious minds like yours. And if you have any questions, feedback or topics you'd like us to cover, feel free to reach out. Till next time, keep exploring, keep questioning and keep pushing the boundaries of what's possible with quantum computing.